So much of software engineering, I feel like there's the whole like iterative aspect to it. But then when it comes to this, like
APIs are forever.
you only got one shot.
Yeah, you really only have one shot. I mean, API versioning conceptually exists, but in practice, probably we could have done without it.
One thing which has been consistent throughout your career has been that you've proposed new projects at companies which have had significant impact. But obviously you can't foresee that impact. For example, you helped start Omega as one of the research projects, so you were deeply involved in Kubernetes. What are some of the ingredients in proposing a project, and not only just proposing it, but actually seeing it materialize, convincing stakeholders and saying, yes, getting people behind this? What are the things that have worked for you?
Well, I think a big factor is the environment. So back in the early days of Google, it was a very bottoms-up culture, and grad school is a very bottoms-up culture in some sense as well. So I think that's a really important part, is like, what is the culture of the organization, and do they support bottoms-up initiatives, or are they much more top-down driven, or customer-focused, or revenue-driven? And certainly something like a startup couldn't afford the luxury of just doing, projects that might be useful. Right. So I think the more scarce resources are, or the more tightly coupled to demonstrating value or demonstrating revenue, that just increases the difficulty and the hurdles of getting started. Right. And there's also a matter of trust with the leadership.
Yeah.
If you come in from the outside to the company or to the organization and you propose an idea and there's less trust in, your judgment, then you have to make a much stronger case. You have to find business metrics, which are reasonable things to ask for, but maybe more effort and take more time to actually, put together all that data. Or, it may be very difficult to get concrete data, or you may need to do experiments first in order to get to the data. So there may be a chicken and egg scenario, things like that. So I think it really depends a lot on the environment more than any specific thing you do, because, like if you can do whatever you want, then it kind of doesn't matter. You can just go do it. On the other hand, if there's a very bureaucratic process that requires, a very large volume of data to go produce, it might be infeasible for you to actually go collect that data and do that project.
Welcome to the Software Misadventures podcast. We are your hosts, Ronak and Guan. As engineers, we are interested in not just the technologies, but the people and the stories behind them. So on this show, we try to scratch our own itch by sitting down with engineers, founders, and investors to chat about their path, lessons they have learned, and of course, the misadventures along the way.
Right. So I thought maybe like a fun place to start is that you mentioned that you closely worked with Mark Ewing when you were an intern at IBM, who's the creator of Red Hat. Any like fun stories that you remember?
Yeah, fun story. So we both worked at IBM in 1991, before Linux existed. And the projects that we actually were hired to work on as interns never really got off the ground. It was a networking management product from IBM, but IBM had historically its own networking technologies and its own networking products, and it wanted to get into kind of more internet oriented products, but it didn't have people with the expertise. They were doing token ring and other things. And so I actually worked with Doug Comer at Purdue, who wrote the book on TCP/IP. Literally, I have a mug that says that.
We had a book club, I think me and Ronak and a few other friends, because we didn't have a background in any of this. We came from, I think, electrical engineering or math. So then we literally had a book club for about a couple of months, literally reading chapters from the TCP/IP book. There's 3 volumes, right? I think we kind of
there's three volumes. So I proofread the second volume or something like that. But
cool.
So maybe I'm in the acknowledgement somewhere.
So cool.
But so I was hired as the nominal TCP/IP expert, and it would have been an SNMP based network management product. And back in those days, I was implementing stuff from the RFCs and whatever. But they were forming a new team, and it just took them a while to decide what should the product be and things like that. They ended up licensing a product and white labeling it. So we actually never worked on it. So we had a whole summer to do whatever we wanted. So for other reasons, which I won't go into, the local area network was very unstable. So we decided to make the RS6000 workstations be able to operate without the network. And back in those days, if NFS became unavailable, and you try to access NFS, it would just hang, everything would hang. Everything would just freeze. So we tried to copy all the files locally. So we created this thing, and we created like 80 pages of man pages
Oh wow.
of documentation where we would, and let me know if the connection to Red Hat sounds familiar, would synchronize files across the different workstations to maintain a set of tools that you could use locally. It would sync also email and groups, and we actually created a whole elaborate navigation system using Emacs Lisp, where you could like navigate email and groups and all kinds of stuff and manage it. Like we wrote 10,000 tens of thousands of lines of Emacs Lisp and shell scripts. It was a lot of fun. I learned a ton just doing that. But the whole thing worked, and they probably threw it away as soon as we left because they didn't understand it. But after that, Mark was graduating a year earlier than I was. He was a year ahead, and he wanted to start a company. So at the time, he was dyeing his hair red, and the company was called, I don't know, the idea was called Z something, I forget. But yeah, it had to do with this core idea of packaging, file packaging, I think. And I think that probably evolved into RPM later, some of the core ideas. But, that all predated Linux by a couple of years. So it didn't really all come together until a couple of years after that. But I decided to go to grad school instead. So there you go.
That's pretty cool. By the way, can you show the front page of that manual again? Mark and Brian's excellent environment.
Yeah, I hand wrote that because we didn't have a printer. If you look that could do that bigger fonts, like if you look at it, it looks
nice.
like
Yes.
Type print.
Yep.
I forget what kind of printer it was, but it was not fancy. So we did write a lot of documentation and try to make it foolproof and all of that. But yeah, it was a lot of fun.
So one thing which is pretty cool in this case is that not only did you build something very exciting, but you actually put together this entire manual of sorts, or man page. This is not something that's instinctive to a lot of interns. Let me preface that. I worked with some interns. Many of them are excellent, but documentation is something that even it doesn't come as instinctively to, I would say, very seasoned software engineers. But you were doing this as an intern at IBM. So what was the inspiration to do this?
I don't know. I have always been kind of self-directed. I've been fortunate to be in positions where I could be fairly self-directed in all of my projects and all of my work. And I kind of think about it end to end from the end user perspective in terms of, what would they be trying to do? What would they want to do? What would be their starting point? What would be the journey? And, even before I knew about any UX critical user journeys or jobs to be done or anything like that, any kind of formal framework. So I don't know, that part kind of came naturally to me, but, in terms of figuring out something, interesting to do and fleshing out the shape of it, the product side, the UX side, the documentation side, I think I've always been, pretty good at that.
So I wanted to...
we could leap ahead to Kubernetes, but like on Kubernetes, I designed the information architecture for the Kubernetes.io site as one of the things that I did.
Oh, interesting. So, okay, that is something we definitely want to get into. I'm just going to take a note of that so that we don't forget. But before we jump onto Kubernetes, I wanted to rewind the clock a little further. Somewhere I read that you built a computer as a kid, and that's how you got introduced to it. Is that right?
It's almost right. So my father worked for the power company. So he was an electrical engineer, but for the power company, he repaired metering equipment. So he bought a kit computer called a Kim1. It was, you can Google it. There's like a Wikipedia page. It was a 6502 based computer. It had a little hexadecimal keypad and a little LED display. They would print out the hexadecimal digits a few at a time, and they would scroll across. I wire wrapped the 4K memory board. So my father, gave me the wire wrap tool and said, here, you need to connect all these wires. So there's like a lot of pins on a 4K memory board back in 1981, I want to say. And I helped wire up the memory board. So once the computer was operational, there's no persistent storage and there's no ROM with firmware or anything like that. So we would turn it on and it'd be a blank slate. But back in those days, there would be 6502 programs in assembly in Byte Magazine. So I'd type in the programs from Byte Magazine. I forget Like there's no assembler, so I forget whether it had the machine code or we had to hand assemble it. But I would type those in. Games like Hunt the Wumpus, I remember, was my favorite. And like words would scroll across the LED display saying you feel a draft or something like that coming through the door. And you have to decide which door to go through, right? Like it's a maze that you have to figure out and draw on paper and can't really see. So that was by far my most favorite one. I didn't do any kind of real programming on my own, just tweaked the programs really that were in there, but I was like 10. So the next computer we got after that was an Apple II Plus, which is what my profile picture on most sites show these days, me typing away on the Apple II Plus. And, there also, Apple II was really, it really amazed me because we'd turn on the power and wow, there would be a prompt and there'd be a basic interpreter. It blew my mind coming from the Kim 1. And we had to buy the pieces of the computer progressively, like extra memory, the floppy drive. We didn't have a floppy drive initially. So again, like I was typing in the programs, but basic was a big step up from hexadecimal machine code.
For sure.
So that was a lot easier to write programs. So I did write some programs for that, but it's like you had to number all the lines and do go-tos. And then if you want to insert more, you have to renumber the lines if you didn't leave enough space in between and things like that. So that required a little bit of pre-planning. So I'd have to write them out on paper first to kind of figure out if I had enough line numbers, space. And but then, I didn't do much really serious programming. Like I didn't start a company or like it didn't occur to me you could make money on any of this stuff or whatever. And until high school, we had a program. I took a couple of things. One, I took a typing class with actual typewriters, and that actually helped a lot. Made me a lot more efficient. And I took because that was considered a valuable job skill back then.
Oh yeah, I've heard.
So our high school offered a typing class, which was not totally normal, but was useful. And there was a programming class. So my high school actually had a VAX 11 750, I think. And I got special access to come in an hour early and play with it. So I did every day for a long time.
How did you get the special access, by the way?
I talked to the instructor and I guess impressed him enough. I was like, learning shell sort, and it's like, oh, we don't do this until like the most advanced senior class or whatever. It's like, just give me the thing. I'll just do that. And so a friend of mine, a very good friend of mine, and I together, we wrote a poker program because with terminal characters, you could print out all the card symbols. So that gave us an idea. Maybe we can build some kind of card game. Well, let's do poker. There's enough screen real estate because these are VT11, VT100 terminals. So, they're not like high-res graphics or anything like that. So we could have limited, it's a little bit better than ASCII art, but it wasn't super fancy. But it turned out we could highlight squares, so we could make white cards. And we could put the little, club sign or spade sign, heart sign on the cards, diamonds. So we did a poker game, and we made it so you could play other players across different terminals.
Oh, wow.
And also we created you could play the program. So we created like a house player that didn't cheat. They would make semi-randomized choices and would actually sometimes win. So it became super popular amongst other students because we left instructions in the lab about like how to run the program because there was like a shared file system. So people would be playing that. So the instructor was a little bit annoyed by that, but just made a rule like don't play it during lab time.
It's pretty cool that they let you run the program though.
Yeah. Another popular thing back then was to leave a fake login screen on the computers to phish passwords for logging in. That was like super easy. There's like no security. Because I had access an hour early, I could just go in and do that. I didn't actually ever do it for real, but I did make the program
for the
record. But we did make the program. It's like, oh, this is way too easy to do. Like, how can we make sure this doesn't happen to us? So, so we tried to figure out like how you could figure out as a fake login. It's mostly what we used it for.
Wow, that's pretty impressive in terms of how you got into programming. So close to this, like let's say for example, going back to the internship with Mark Ewing. Now you decided to go to grad school. Mark decided to start his company, and by this time you had enough experience with computers to know what the potential would be. And around that time, you also saw a few years after that, you saw a lot of these computer companies get started. What made you choose grad school as opposed to, let's say, working at one of these companies, or even with Mark for that matter?
Yeah, that's a good question. Surprisingly, computer science wasn't necessarily an obvious choice for me to go to college because I was like good at everything in high school, and they said, well, you're good at math, you should do engineering. And I was just going to go to the same college my dad went to, and it is in Indiana. I grew up in Indiana, Purdue. And my dad said, hey, they offer computer science. You like computers, you should do that. So it's like, okay, that sounds like a good idea. I'll do that. That turned out to be a good choice.
Yeah.
It just worked out well for me. But once I got into school, like I mentioned, I was working with Doug Comer. I hung out with grad students all the time. Like from my very first semester, I was lucky to have a great set of teaching assistants in the intro programming class who would answer all kinds of questions, let me hang out in their office. They taught me how to use Make and RCS, the version control at the time, a bunch of bash shell stuff. It was just Bourne shell. And I learned a lot from them, but, also, so for the very first semester, I just kind of expect grad school was kind of a normal thing. Like everybody, I hung out with a lot of grad students. I did research for professors. I implemented like Sun RPC and XDR for another research project for another professor. The ACM chapter, student chapter, had all grad student leadership for the past, preceding decades. Before that, I think I was the first undergrad president of that student chapter ever. Purdue had one of the oldest computer science departments in the country. I think it started in 1962 or something like that.
Oh, wow.
So they had a pretty old. So I don't know. I just kind of became a thing I was just expecting to do at some point. And I did find that I actually like studying problems and studying the solutions. And that is something that is carried forward with me in terms of how I approach problems. I'm a bottom-up thinker, I've realized. I like to study the problems, study the solutions, look at lots of examples. And from there I infer, like, well, why didn't anybody ever try it this way? And then I could try it that way.
So I wasn't planning on going in this direction, but I feel it's a suitable question. Again, if it's not a good question, feel free to tell us to move on. But this is something that has come up a couple of times on this podcast around just studying computer science at this point. Like going back to when you got started, you were typing in hexadecimal code on the computer to make it work, then writing BASIC to, I would say, students today have it quite easy. They can write English and they get a computer program back. But there is a lot of benefit to studying the problems themselves to develop that maturity of the problem space to come up with better solutions. But today you see a lot of people questioning, well, whether computer science is something that's worth studying given where LLMs are, for example. Do you have a take on that in terms of, is that still a domain that's worth getting into? Or is it like, well, AI is going to replace all the software engineers?
I don't know that AI will replace all the software engineers. I think it's too early to say where the bounds of what it can do will be and how rapidly it will improve. Certainly, I was actually just reading Steve Yeage's really long blog post.
Yes.
I know Steve a little bit from Google. He's great. But yeah, I mean, definitely has been my experience up until very recently that there were a lot of weaknesses in terms of what it could do. Obviously that will improve. Like I said, how fast, it's hard to say. I was working on some very specific code earlier today, and honestly, it didn't even occur to me to try AI on the code because it wasn't a large volume of code. It was more like tight, intricate code, and not really algorithmically complex, but more kind of data structure type syntax kind of complex. And I think those kinds of things require a large amount of context. Like you may have to know, I don't know, thousands of type declarations, or you may need to know general patterns across type declarations that are not explicitly specified, or things like that. I think some of those things will remain to be challenging for some time. But I always, I have seen the analogies that maybe AI can replace the junior developers, like in Steve's post. I guess that's to some degree plausible. Certainly something I did as an undergrad was I wrote an assembler for an instruction set architecture. And I did that in a single sitting, and it worked with no bugs. But, that is something that's probably straightforward enough in AI. And it's, just a large volume of kind of relatively boilerplate code. I'm sure AI, once the context window is big enough, could do something like that relatively accurately. So, if we can figure out how to leverage the AI to accelerate kind of those uninteresting, generate lots of boilerplate parts, because they seem good at kind of interpolation and extrapolation from examples, then I think it can relieve a lot of the tedium of programming that some people, dislike, and leave the interesting parts. I've been pretty lucky in my career that I get to mostly focus on the interesting parts because, once any project grew, to more than a handful of people, I was spending more time reviewing code than writing code or doing design work or doing some other part of the tech leadership role, right? So, maybe more engineers could do that. In some sense, it's kind of a superpower. If you have a vision for what you want to build and it's a mere matter of coding, maybe the AI can do that coding for you, but you still have to have someone to envision what is the thing to build.
Do you have any advice for students who are probably just getting started, who are either about to graduate or maybe getting into school, for how to develop this kind of intuition when there's still AI which can help them with a lot of the boilerplate code that you said, but intuition is not something that they're going to get from that machine. It's something that they still have to develop through experience. Go ahead.
Yeah, I think different people learn in different ways. Like, not everybody is a bottom-up thinker in the way that I am. And I actually haven't seen data in terms of like what categorizing different kinds of thinkers and how many of each kind there are, things like that. That would be interesting. Maybe the educational community has something along those lines, but certainly for the like lower grades, high school and below, there's some issues. And some people are more hands-on or excel better more in kind of project scenarios where you're building something, and other people can read from books. Some people like video. So for me, I learn a lot just by looking at examples. So, if AI were to generate a lot of code for me and I could look at it and maybe try it in a playground, that would probably work well for me, even though I didn't type the code in, right? Because I feel like I don't need to type the code in order to extract value from it. One thing I do quite often is look at blog posts from other people to get an idea of how other people think about the system or the interface, because I know not everybody thinks like me. So that helps me think, when they're presented with this is how they react to it. So I think there's some element for that. It actually took me a long time to realize how I best learned. It was something I kind of did unconsciously for a long time. But it's hard to say. Also, I went through a certain journey to get where I am, and if I had gone a different path, would I still be able to, have the same intuition? That's really hard to say. I grew up during the PC revolution, and I actually read somewhere, I forget where, that a disproportionately large number of kids who grew up during the PC revolution did a lot of this programming on their own while they were kids. It's just kind of a new, exciting thing. Not cool, certainly, but it was new and challenging. Now the environment is quite different. Probably no one would think of starting with hexadecimal machine code for whatever processor they're using, but that understanding of how computers work really carried through with me through earlier parts of my career, where I leveraged it quite heavily, like at Transmeta and Peakstream, and in grad school, and doing supercomputing and things like that. And then also, even now, I feel like I just kind of have a pretty good intuition for how computers work, what the performance is, things like that. Like, I know how many instructions stuff will compile into. So
I would say not. I don't think many software engineers know that, including myself. How many instructions will it take for this thing to compile? So that is pretty cool. One thing, as you were describing how you learn, I was recognizing is it's a lot of self-awareness in terms of describing how you learn. I don't know if I can do that, at least for myself, but it's something
I couldn't until the past year or so, when I thought about it really hard. So
that's a reminder to a lot of us to think about it, at least. I don't know if we'll come to a conclusion, but it's a good exercise regardless.
Yeah, it is a good exercise. I actually went back and reflected through my whole career, back from the beginning when I was programming with 6502 machine code, and I found that to be a useful exercise. I just wrote out a narrative of my entire career through the beginning to kind of see what are the common patterns, what did I like, what was I good at, what did I spend the most time on. Like, I've realized, wow, I spent a lot of time programming in C, more time programming in C than all the other languages put together.
Oh, wow.
Just because that's what I learned at the beginning of college, and then I did a lot of systems and compiler work in C, and embedded systems and things like that in C. Then, later C++. But then, by the time the Go project started around the time I started at Google, same year. And I was a compiler engineer, so I talked to Rob about it. But, I knew from Java how long it took to build new language ecosystems. And I didn't think I wanted to be doing it for quite that long, so I opted not to do that. But, it is, and it's impressive what Go has become today, back from, what it started, I guess, I can measure it back to when I started at Google 17 years ago. So,
Damn.
but 20 years was my estimate, so it wasn't too far off.
Yeah, for sure.
What were some of the other takeaways from your reflection about your career?
Well, I did spend a lot of time on these lower level kind of systems and infrastructure, supercomputers, architecture, compilers, networking, distributed systems, threading. Like I've written multiple different threading, all the context switching and everything. Yeah, so the center of gravity of my experience, I would say, was in that area. So when I was thinking about what I want to do, I was thinking, do I want to go back to that kind of area of strength, or do I want to go do, something different, or continue to kind of branch out in areas I've been focused on more recently. So that was just useful for me to just sort of see how I felt about different things going forward in my career, since I was at the point, the reason I was doing this reflection is because I was already thinking about leaving Google at the time and deciding what I wanted to do next.
I see. Were there like specific periods of like hypergrowth like in your career, and were there like any patterns to that?
Hypergrowth in terms of career trajectory or
Yeah.
learning?
Both,
or
like either or.
Well, I learned a lot at Transmeta, I would say. And, in terms of career growth, like position, I don't think I was there for 5 years. I don't think it was necessarily exceptional, but I did learn a ton as my first, real job after grad school. And it was my dream job in many ways because, I mentioned that experience going from the Chem 1 to the Apple II, where I would turn on the power and there would be a prompt. And I wondered, how did that work? So, even though I took architecture classes and digital logic and, a bunch of computer science and engineering classes in college, including building a computer-controlled car with Gene Kim. You can ask Gene about that if you have him on the show. We went to school together. I still feel like, I didn't really get a deep understanding of that until I went to Transmeta, which was a great experience being a software person at like a relatively software-heavy hardware company in Silicon Valley. It was literally right across the street from Intel. I got the silicon experience of Silicon Valley. And things like, tape outs taking 12 weeks and bring up when the chips come back and nothing works. How do you actually figure out what's wrong and make them work? It was also at a time when the industry was transitioning from 130 nanometer to 90 nanometer process, and the leakage skyrocketed. Intel's chip at the time was a Pentium 4, which was reaching the frequency ceiling of 4 gigahertz around that time. And it was just before the multi-core era. And also the industry was transitioning from aluminum wires to copper wires and starting to outsource to a little fab called TSMC. And
little fab.
like all these changes were happening at the same time. And it was just a fantastic learning experience. When we started doing the 90 nanometer chip, I had a machine on my desk with a ball socket that I could just open and close. So I get like a tray of chips. I'd slap in a chip, close the socket. I could change the frequency and the voltage and see where it broke. And then I would have to like debug that with the circuit people and figure out like why can't it add. So there would be like certain combinations of bits in the inputs where you would get the wrong result. Like all the upper bits would be 1 where they should be 0. And it had to do with the way the dynamic logic wasn't fully charging within a clock cycle. But to work around that, what I did was rewrite the static compiler and the dynamic compiler. So Transmeta, was what we offered to the market was low power x86 chips. They were implemented as a custom VLIW, and we did dynamic binary translation from x86 to VLIW. So there was a dynamic compiler in there and an interpreter, and that was super awesome. All the sci-fi technology worked awesome. We had hardware transactional memory. And yeah, so by changing all the instructions, it turned out the memory unit contained an adder because you need to add to index into arrays. So I could actually replace all the ALU ads with memory unit ads, and it would be a little bit slower. But the trick was the memory unit didn't compute the condition codes. So if you wanted to do a subtract and then a conditional branch, it wouldn't work. So I had to compute the condition codes using bit logic. So, like if there was a branch following that the arithmetic operation fed into, then I'd have to generate the instructions to emulate the condition codes. But then, once we did that, we could find the next bug, because now adding would work, and we could find the next bug, and we could find the next bug and the next bug. So we could work around a certain number of bugs in software before the next tape out, because, a full tape out would take a quarter. If you taped out some metal layers, maybe it would take a month. This is another cool thing in Silicon Valley is, and probably other places too by now, is you could actually send chips to a FIB, fixed ion beam machine, and it would push around atoms on the chip.
What?
Can you describe that a little more?
Yeah, so let me look up. Does this thing have chat fixed?
Yeah, it has a chat on the bottom right.
Chat.
Yeah, focused ion beam. So check out the Wikipedia page. You can think of it as kind of similar to a scanning electron microscope, but it pushes the atoms around instead of just looking at them. We also needed scanning microscope pictures to see all the copper wires that weren't formed properly. We had a big challenge with vias for a while. So vias are the wires that go between layers. Like there's alternating layers of metal and silicon, and there's little holes in the silicon to allow metal to drip through. But because of the viscosity and everything, like when the copper process first started, they either didn't go all the way through, or they splattered out and shorted things out. Like we looked at a lot of photos saying like, why aren't the vias working now? Why aren't the vias working now? But anyway, it's super cool. If you put dark gates that are disconnected onto the chip, you can either do a metal tape out to connect them in via wires in the upper layers, or you can, just push atoms around. So
is this like later on in your career it was pretty impactful, because like, when you're debugging some issue in Kubernetes, you're like, back in the days, I gotta put out a microscope, to look at some of these things. So this is really like a walk in the park.
I mean, it's mostly the circuit folks who dealt with that sort of things. We had issues like when the wires bent 90 degrees in one orientation, the optical process would make the wires fatter than in the other dimension. So then you get induction and all kinds of electrical effects. So I wasn't involved too much in that, in discussing what is the effect on at the instructions level, like in terms of, what do we need to add extra latency between the instructions, because it was a statically scheduled VLIW. So I could just put more padding, or I could use different registers from the register file. There's a variety of things I could do to try to make something sort of mostly work, or at least work enough better that we could find other problems. Now with Kubernetes, I think there's a different approach I applied, which is because I designed so much of the architecture, I found my understanding of the system was very stable over time, even without having looked at the code in detail or recently. Like I would just know how the components interacted because I understood the overall system design. So, there weren't a lot of changes to the system when I was actively working on it that would kind of disrupt my mental model. It's like, I know how status works because I proposed that design. So, like, I know how this component should be interacting. So I can say, did you do it this way? Did you do it that way? These are, it sounds like it could be this problem if you didn't do it the way I expected. So, a lot of the times with Kubernetes, I could debug things without looking at the code.
That is pretty impressive. I want to get into some of the design aspects of Kubernetes too. But before we get there, one more step along the way. So you mentioned you joined Google around like 2007, 2008, if I get that
2007,
right.
Yeah.
And initially you worked on some of the multithreading project, if I remember correctly. And then you got started on the Borg project.
Yeah, so that's another example where I chose that project and identified like all the sub-projects and moved them forward and started a company-wide initiative to move the C++ code from single threading to multi-threading. And wrote documentation and started an education program and evangelized it. So, kind of similar to the, to the manual in that sense. So we brought in folks from the education part of Google, and folks from like all different parts of Google to kind of evangelize that approach. Because Google started in '98, also just before multi-core really took off. They started with cheaper single socket boards that they design, or at least that's what they moved to very early. So early on they started coding, and this is before the C++ threading standard and stuff, which also my group also was involved with getting that off the ground. But so Google did have its own internal thread primitive library, but at the very beginning the assumption was, well, threading is bad in Linux, there's no C++ threading standard, there's only one core anyway, so just use a single threaded event loop and that'll be more efficient, it'll get higher throughput, which is true, but it wasn't true by the time we had 8 cores per machine, right? So that was, but by that time Google had a massive amount of code already. Java did better because it had threading, had concurrency built in. It had concurrency primitives, it had concurrency libraries that were pretty good. It had thread pools, it had mutexes, all of that. So the Java code was in better shape in that regard.
Do you run into a lot of pushbacks during that evangelization process?
Mostly around prioritization and urgency, right? So like my team built a multi-threaded HTTP server and I wrote a little bit of the code in the core, and web search eventually adopted it, but like 2 years later. And by that time I'd already moved to Borg, right? So, that code is still used now, I think. So it was successful in that regard. It just took a while.
One thing which has been consistent throughout your career has been that you've proposed new projects at companies which have had significant impact, but obviously you can't foresee that impact. For example, this project we just talked about is one of them. You helped start Omega as one of the research projects too. You were deeply involved in Kubernetes. What are some of the ingredients in proposing a project, and not only just proposing it, but actually seeing it materialize, convincing stakeholders and saying, yes, getting people behind this? What are the things that have worked for you?
Well, I think a big factor is the environment. So back in the early days at Google, is a very bottoms-up culture, and grad school is a very bottoms-up culture in some sense as well. You have to convince a professor or work together on an idea with the professor, but it's pretty open-ended, and there's lots of different potentially viable projects that you can undertake. So I think that's a really important part, is like, what is the culture of the organization, and do they support bottoms-up initiatives, or are they much more top-down driven or customer focused or revenue driven? But the environment in Google at the time was still such that pretty much anybody could start a project. If it looked like it was useful, you could get more resources, and that was a good environment to be in. It is different now, I would say, in that regard, and not for bad reasons or anything. And certainly something like a startup couldn't afford the luxury of just doing projects that might be useful, right? So I think the more scarce resources are, or the more tightly kind of coupled to demonstrating value or demonstrating revenue, that just increases the difficulty and the hurdles of getting started, right? And there's also a matter of trust with the leadership. If you come in from the outside to the company or to the organization and you propose an idea and there's less trust in your judgment, then you have to make a much stronger case. You have to find business metrics, which aren't reasonable things to ask for, but maybe more effort and take more time to actually, put together all that data. Or, it may be very difficult to get concrete data, or you may need to do experiments first in order to get to the data. So there may be a chicken and egg scenario, things like that. So I think it really depends a lot on the environment more than any specific thing you do, because, like if you can do whatever you want, then it kind of doesn't matter. You can just go do it. On the other hand, if there's a very bureaucratic process that requires, a very large volume of data to go produce, it might be infeasible for you to actually go collect that data and do that project.
So moving forward a little bit, obviously we have been touching on Kubernetes a little bit, but can you share a little more about how you got involved with the project in the first place?
Yeah, so, I started on the Borg project as a follow-on to the threading project in 2000. I started in January 2009, nominally to make the Borg control plane more multi-threaded, because that was kind of what I was doing at the time.
Was that kind of a jumping off point for you to get into Borg as well?
It was, yeah. the board cells, the clusters, were growing exponentially in core count, and the applications were not taking advantage of those extra cores at the same rate. It's because the number of cores per chip were doubling, the number of sockets were also doubling at that time. So the scale of the number of workloads running on the systems and the number of users were growing exponentially, effectively. And so the team was kind of running to stay in place, effectively, trying to keep up with the exponential growth. But there are some parts that have been parallelized, like the scheduling, computing, what's called the scoring function, computing the suitability of each machine for the workload. That was done in parallel. It's kind of an embarrassingly parallel problem, that part of it. But many other parts were not. And so I actually joined the Borg team initially to do that. And the first thing we had to do is instrument the Borg master with that was the control plane with metrics, kind of at the time Borgmon, which is what inspired Prometheus. There was only one metric when I started that was used in production, and it was called the machine ping period, which was the 80th percentile of the machine response time. But because it was single threaded, it was sometimes processing machine responses and sometimes doing scheduling and sometimes replying to requests. So you could kind of infer that something was slow if that number got long, but you didn't really know what exactly. There's two most common causes, but I've decided, look, if I'm going to parallelize requests or something like that, I got to know how much time is spent on a request, what kind of requests are we getting, things like that. So I instrumented everything that I could possibly want information about, and we built monitoring dashboards. That actually turned out to be super useful in production for understanding what was going on, but also just useful in understanding the system. So I also just looked at, what are all these clients doing? Why is it getting so many RPC calls? And it turned out that a very large number of clients were just polling continuously for information. And this was because there was no change notification system. There's no watch API. There's no watch API, right? So more than 99% of all requests were read requests pulling for information from these higher level controllers that were trying to do, batch admission control or cron scheduling or whatever it is that they were doing, right? Map reduce jobs, checking for whether the job is finished, things like that. So that is one of the first things I observed, so I went and just decided, well, all I need to do is parallelize the read requests and that'll be good enough. And it was for the most part. Right. And, but also, I learned that, maybe there should be a change notification mechanism for the naming for the service discovery system, which is called BNS, the Borg naming system. The host IPs and ports dynamically allocated for all of the Borg tasks were pushed to Chubby, which is a key value store, Paxos-based key value store that inspired Zookeeper, and then later the Raft implementations, etcd and console. So that was like one of the first uses that I'm aware of using a key value store like that to do service discovery.
Which is pretty common these days, by the way. Like today, that is like the status quo.
That paper was published in 2006. I think it's been common ever since then. Yeah. But other information was not pushed there. So, one of the core ideas in Omega was that we would have that kind of a store as the center, so everything could be a controller. Because Borg had the core that implemented jobs, tasks, Alex, machines, was this totally different kind of synchronous state machine checkpointing model, and everything else was a controller that was asynchronously polling. So I said, well, why not just make everything asynchronously poll? That's a way more extensible model.
So one thing which is interesting in this case, you mentioned when you were looking at Borg, there's only one metric used in production. Now, for people who think about Google, they think about, well, Google's infrastructure is extremely reliable. Obviously, every metric you can possibly imagine would be instrumented. There's this amazing Google SRE book that talks about how to monitor services in production. But this is back in like 2007, 2008 era. Was this pretty common at the time?
I'm not really sure about other systems. I think the user-facing systems had more components, like the board control plane was just one component, really. The core was just one component, right? And like everything was built into a monolith.
Yeah.
And the team was relatively small at the time. I think the team size has grown by like 20x since then. So, certainly it's not common now. Back then, I think probably not. I think it's just probably because this was Borg was started in the beginning of 2004, end of 2003. So, it had its 20th anniversary this year.
Double image than Kubernetes.
Yeah. And, at the time it was pretty early and sort of everything was on fire, right? Like the clusters were growing exponentially and all the workloads were getting migrated to Borg. And, so I think, just other things were the SLA as an internal system, it didn't need to provide 5 nines or even 4 nines of availability at that time. It's kind of like everybody has to be multi-homed. Clusters were taken down due to power maintenance on the bus ducts and the generators on a regular basis. So, it's like, your service should be in +2 anyway. It's like, if the cluster's down, that's fine. But Borg actually operated on a principle of inertia. Everything just keeps running, even if the control plane is down. So, the control plane could go down for an hour and everything would keep running and it would slowly degrade as machines died or rebooted or whatever. But if you just stop all the automation, that's the cause of most of the churn. It's like just, shut off everything that's rebooting machines. It degrades much more slowly than that.
Well, this way of describing, like in this case, how Borg worked, I think Kubernetes falls in a similar category. Again, depends on how you deploy the workloads on it. But inertia, I forget who had mentioned this to me, but they said something on the lines of objects in motion stay in motion, objects at rest stay at rest. And when
That's right.
that someone described it, I was like, oh wow, this is such a nice way to describe the property of the system.
That is exactly it, yes.
So you started the Omega.
You wanted to come back to, this is a long tangent on how did I get involved in Kubernetes.
Yeah.
So after doing the Omega R&D for a few years, a few things were happening. But one of the most relevant things that was happening was cloud was becoming a higher priority. Like it was a relatively small, nascent product, but it was on the road to GA. So it actually reached GA, I think, December 2013. So during 2013, Google was already thinking about how to accelerate the cloud effort, how to start ramping it up. The preceding years to that were kind of more R&D like too. Like we had to change the way we operated our data centers, for example, because it wouldn't be acceptable to just take a whole data center offline and say, yeah, your VMs aren't going to run this week. Is that okay? Right? We were used to that, but we had to actually change things like that. Put in extra bus ducts and make sure that power would never go out, things like that. But by this time it was considered to be ready. So they already started thinking about how can we apply more of our internal infrastructure expertise to cloud? How can we accelerate cloud? So Joe Bita and I started chatting. I mean, we had met with Compute Engine as a Borg customer, but in terms of working more closely together, we started chatting at mid 2013. And I think we may have even started reporting to the same director in Mountain View, because Joe was already looking on to do to the next things, like Compute Engine was off to the races. He was looking for something new. And that's when we started discussing concepts like labels. So we actually proposed the labels concept based on a bunch of my observations for Borg that he thought would work well in cloud also. So that was the origin of labels in both Google Cloud and in Kubernetes there. And then in August, something I talked about on Twitter and in the Medium post was this thing called the Unified Compute Working Group.
Yeah.
And that was started by a couple of directors to bring together a group of folks from cloud and from Borg to discuss, if we were going to build a cloud product that was more like Borg, more like something Google could use, what would that look like? Because App Engine, which had existed for a few years already, platform as a service was considered to be too restrictive to run most Google workloads. It ran internal IT workloads, like MemeGen, I think, runs on it. But,
An
like
important product, I would say.
but, web search and Gmail don't run on it, right? And VMs were considered, Google had never used VMs. Like that was basically considered a non-starter. They're too expensive, too opaque, too hard to manage, which I agree with all those things. So, something based that's container-like made a lot of sense. And Joe had discovered Docker, which I think, was announced in 2013 sometimes. And, it's pretty clear to us that, we could see how our lower level resource management C group containers, which we added to the kernel, would fit into that higher level user experience of containers that we never bothered to build, because we did things like we would roll out standard base images to all the machines and then create a chroot on the machine for the Borg task to run into. So we thought, the file system is not a problem because it's like decided, like we control the file system, right? And it's not like we're running arbitrary third-party applications, because they have to be instrumented with Google's authentication system and Google's monitoring system and Google's logging system and everything. It's sort of this pervasive NIH effect. We could reuse libraries, but reusing whole components was really hard, even to things like the build system and whatever. So what Docker did there was really interesting, and then it solved pain points that we had, but we didn't know really what to do about or how important they were. Like, how do you reproduce the production environment in development? It's like, well, everybody can just launch a Borg job. That's not a big problem, right? Like, we had at low priority, you had free quota. You can just go do it.
Google at the time had hard problems, not these easy problems. So a lot of the things were just not looked at.
Yeah, but but Docker had a really interesting user experience, and that was before the Docker file. So you could start a container, apt-get install some stuff, and snapshot the image, and it actually was really easy to iteratively kind of build up your image and then reuse it. So that was super interesting. So we immediately all agreed, okay, it should be Borg-like. I knew from my Omega and Borg experience that I didn't want it to be too Borg-like. I wanted it to be more Omega-like. And, in the end, Kubernetes was really more like open source Omega than open source Borg. It's like Omega v2. And the initial assumption was that it would be a cloud product like Compute Engine and App Engine. So there's several proposals from different people. There was a long PRD that we put together that had like a section in common and then a bunch of viewpoints from participants on, their thoughts. Like everybody came with their own ideas and their own vision for what it could be. But all the initial proposals, through the summer and fall were kind of in that shape, I would say. And I started working on the API design, and I've shared some like screenshots from it and stuff like that, as well. But that basic, object model shape, taking the Omega scheduling units, those became pods, the controller concept, decoupled functionality like auto scaling would be a separate resource, things like that. That was taking shape pretty nicely. So in December, I presented that kind of API design, initial API design, and Brendan developed a prototype for 7. So the open source proposal, I think, came in December, and that definitely shifted the conversation, at least amongst all the engineers who thought it was a great idea. Like, yeah, we don't want to be Hadooped. Hadoop is a verb, right? Or like the Chubby Zookeeper is a good example. We didn't open source Chubby, and pragmatically we can't really open source Chubby. So the open source community built something that is similar. Takes a bunch of the ideas that we published, but not something we could run internally. Yeah. So if we wanted a cloud product, that would be one way to do it, because GCE. So remember, December is when GCE reached general availability. So it was not widely used at that time. So the question is, how do we gain market share? And I think we talked about this in the documentary also. So we had many the more we discussed it, the more reasons we came up with for why open source was a great idea. Like, whether it's disrupting the cloud status quo or shifting everybody from VMs to containers. Like that was a big part that Eric Brewer talked about at the 10th anniversary event. That video's on YouTube. I know Eric did feel strongly, and we thought, containers, yeah, we understand containers. We know, everything we need in an ecosystem to make containers awesome. And that's part of why I got involved in CNCF as well, to build that initial product portfolio, like, Prometheus. Like, oh yeah, we need something like that. Leading up to 1.0, I wrote about this in the 1.0 blog post, is when we integrated Prometheus metrics. That ended up being a very synergistic relationship between the two projects. I think the simple exported variables for Go didn't quite do it for us for various reasons. I think the issue I linked to in my blog post discusses some of the rationale for that. But that worked great. It's created by some ex-Googlers.
Yeah.
And getting it into the CNCF worked very well for both projects. Yeah. So anyway, in terms of shifting folks to containers, I mean, that was really, and to Google, as a consequence, was kind of the big pitch. We have credibility in that space. We know what to do with it. We can kind of blaze the trail. We can create the de facto standard. There was a lot of concern that Mesos, which a lot of the larger companies were using, could be an option, or that Docker or someone else. There were dozens of projects at the time would create the de facto standard, or that Amazon would just create the proprietary standard, like S3, and then everybody would have to copy it, right? So if we started with our own proprietary standard and Amazon did, we might eventually have to launch a second product that matches their standard, which Amazon had to do to match ours. So
well, people keep playing catch up. There are a bunch of interesting things in this journey of how Kubernetes came to be. One thing that you mentioned, that there was this unified compute working group. Typically, when a lot of these working groups come along, I want to say less than half of them are successful. I've seen a few of them, not very many, but that's been the general observation. It's mostly because too many cooks in the kitchen problem in some cases. In other cases, because it's very easy to get on a whiteboard and brainstorm ideas, but you don't actually get to a place where you have something tangible to work with, which you can take forward. But in this specific case, all of you came to, I want to say, in the ballpark of what Kubernetes is today, or at least had the general idea. The direction was similar. What made this working group what made it functional, in simple words?
Well, I would say the whole working group, a lot of people were involved at the beginning. When it came down to actually figuring out what to build and building something, a much smaller group kind of self-selected and started working together. So we had a bunch of folks from Borg who were very interested, both on the control plane and on the node side, like Tim Hawken, Don Chen, Eric Toon, Victor Marmal, Rohit Nagal, Vishkanan. They all came from the node side. And, 3 of them went to go work on libcontainer with Docker. And, the rest were working on Kubernetes directly. Also, they were building things like cAdvisor and Heapster, which we were using for telemetry. So we had all been working together for a while, for years up to that time, to varying degrees. And we got our working relationship with the cloud side, I would say, came together over the course of roughly a year, I guess, because Joe and I started talking in the summer of 2013, and then we open sourced in June 10th of 2014.
Yeah. It's a really fast run up to open source, by the way.
Yeah. And really, from the prototype in December, which I think the initial prototype was in memory and in Java, and it was Vile and Brendan and some combination of folks rewrote it in Go with etcd and Docker and Salt. And we decided to just start working on that, and additional people came on board. It so happened that Daniel Smith came off another project in maybe, I want to say, February or March, sometime in that time frame of 2014. Also, at the beginning of 2014, the cloud and the internal infrastructure organizations were officially smushed together. Um, and yeah, and we started working on the code base together. Joe introduced us to the cloud networking folks, so we could figure out, is it possible to implement IP per pod, and how to do that with the networking routes. In parallel, we were doing a bunch of due diligence on how we would implement containers with Docker. Like, hey, Docker doesn't expose network namespaces. How are we going to do that stuff? So kind of doing due diligence and validating our ideas at that stage, but we still didn't have approval up until the beginning, sometime mid-May, maybe.
So you were building towards it, but you didn't have the
approval. We were building towards it. So this is why Joe gave a presentation at GlueCon in May and presented container VMs, I think it was called, and it was running this simple Python agent that Tim wrote that had the initial container manifest, and that's where the term manifest comes from in Kubernetes. It would start a few containers in Docker on a node, and we open source that simple thing as dipping our, a way to get something out. We didn't need approval for that, really, and eventually we got the green light, and we open sourced what we had. Like, I wrote about this in the blog post.
Yeah.
We just open sourced what we had, and we had to rename task to pod, and there was no real control plane in the beginning, and so we had to go change it to actually kind of reflect the design I had in mind. And that took 6 months ish after we open sourced it. But the community was awesome. The community was great. I think Clayton Coleman from Red Hat at the time started committing within like a week after talking to him at DockerCon.
That's very impressive.
So yeah, it grew really fast.
So in a way, like the real release was 1.0, and a lot of the architectural pieces and the API aspects haven't changed since, or like you said, fundamentally the way system works hasn't significantly changed since then. It's a lot of the features have been added over time. But that brings me to this part. Like, you were the architect plus the API design lead from Google, and I would say the Kubernetes API, as someone had described, I think Kelsey or I forget who had described as like the declarative API to build infrastructure on top of. It's kind of like that. It's not just an API or it's not just a container orchestrator anymore. People use it for various things like crossplane, for example. And this API is something that in a way forces one to do things right. Which, like, for example, level triggered versus edge triggered, for instance. What were the motivations that led you to coming up with a design like this?
Well, it's really those lessons learned from Borg and Omega. And so, for example, another thing I observed from Borg is that I had this ad hoc RPC interface. So the RPCs, it didn't really have a firm concept of resource. It's not a REST API, it's a RPC API. And task was not a first-class resource. Job was the first-class resource, and that was an array of in tasks. And it had some task operations, but the task was not a first-class thing you could create on its own. So that ad hocness made, even with the small number of concepts that Borg had, made it really hard to learn how to build a client and understand how to build a client, which is something, that I had to do. And as I was trying to collect more telemetry and figuring out how to instrument the clients and figuring out how to upgrade clients and do all kinds of things, it was obvious to me that it was super painful, and making it more consistent would be useful. Also, in the configuration tool, it didn't have a first-class plug-in mechanism the way Terraform did, but it was otherwise kind of Terraform-esque. But it had a lot, and that was developed by Marcel, who's doing Qlang now. I think around 2005-ish, maybe. It also had a lot of ad hoc things, like in order to diff the desired state in version control with the live state, there were a bunch of special cases that had to be hand-coded. It's like, well, this thing is going to change, and this representation of the value is going to change, and this other thing you actually have to compare with this different field instead. And like, it was a total mess, because it just grew organically, right? It was an afterthought.
Yeah.
And I see a lot of that in Terraform providers as well. So this is what, if you've seen AIP.dev,
Yes, I have.
we've been developing a body of rules to try to, so AIP 129 we just added recently, shortly before I left, to try to tell people, like, don't follow these, practices that will cause you problems down the road.
By the way, for folks who might not know AIP.dev, I've looked at it. I highly recommend folks check it out. But can you briefly describe what it is?
It is a set of API design conventions that's fairly well structured. It was created by Google and is used by a bunch of other companies now that have ex-Googlers or who otherwise use gRPC. But it's about how to create resource-oriented APIs with gRPC and Proto, and follow some best practices and facilitate automation. For example, you can specify field behaviors like this field is immutable, or you can specify, this argument to the RPC is the resource, and have some standard resource properties and things like that. In general, my opinion is the more standardization, the better. So, it reduces flexibility, but it also reduces design decisions and makes it much easier to integrate clients. So I'd say the AIPs as they are didn't start with that end goal. I kind of pivoted them in that direction. But yeah, it's what Google now uses as the basis for its cloud API standards. But the older APIs don't, follow all the rules. So there's that. But yeah, so anyway, consistency. So I also knew that because of all these other systems built on top of Borg, that in the controller model would all be more peers instead of layers. We needed an extensible concept space. So in Borg, what happened is there were some places in the job request where you could stuff extra information, and these higher level components would just use that to stuff their own information. So they wouldn't have to use yet another storage system to store their own state. They could just squirrel it away in the job, send the job to Borg and go look for that information there. So, I knew that we really wanted to be able to, even if it were in code in the beginning, which it was in Kubernetes, that we could add additional resource types, more like cloud, right? Like cloud expects that you'll keep adding more services and more resource types. So if you kind of build a system with that in mind from the beginning, then you try to create some structure around that pattern. And it wasn't fully extensible, but even Red Hat was extending it from the beginning with their own types, and they were doing it in code instead of in CRDs or something like that. And that worked for us in the beginning. Like they added deployment config and project and some other APIs along those lines. So that gave us an early test that yes, the model was extensible, at least from a code perspective and a pattern perspective. In terms of the declarative model, I knew I wanted something way simpler than Borg config, because the Borg config tool was fairly complex. It did these ad hoc translations and ad hoc diffs and some ad hoc orchestration. So like the replication controller, when we decided to create the deployment API, that was actually modeled after Red Hat's OpenShift's deployment config. But I knew that was a pattern that I wanted to do to push that orchestration server side so that it wouldn't have to be in every client, because it was already getting painful between the Google's command line tool gcloud and the Kubernetes command line tool kubecontrol, or before that it was kubeconfig, and before that it was cloud config, and a UI. If we wanted to have a UI and do a rolling update, you can see this in AWS, where I think CloudFormation had some rolling update functionality for VMs, but if you used any other surface you couldn't access that. So, that was important to sort of have a position that, we don't want complicated orchestration on the client side as much as possible. We just want to create the resources and have controllers do the orchestration. That's what they should be good at. Also, I wanted this kind of simple declarative model, so that's where I started fleshing out the ideas for that. And, first of all, bulk operations, I wanted kubecontrol to not just be one command, one resource, but I wanted the commands to be able to apply to an arbitrary number of nouns. So create dash F a directory, delete dash F a directory, or a list of resources. And that really was kind of a building block towards apply. Issue 1702 is where I discussed the origins of sort of the model there. And I wanted the desired state in Kubernetes to be not just what a human would apply from version control, but would be the union of all sources of truth for the desired state. And that was kind of a controversial position, but I knew that there was no like hard line between what you would want to automate and what you would want to express declaratively in version control necessarily. So like horizontal autoscaling is the canonical example. The replica count becomes something that's controlled dynamically. You could say, let's have a separate value that an autoscaler can control, and you would report back the actual value. Well, that's where you get into this custom diffing sort of logic where you have to know that, there's this other value I need to look at, and I need to go, invoke this other operation to change that value. And it just becomes much more complicated. So I wanted a model where, whether it's a default value or set by mutating emission control, although that came much later, or set by an asynchronous controller, or set by another command line tool, or whatever it is, I wanted to be able to merge all those together into a single declarative intent in the API server. So that's where the three-way diff came in, where we would diff the previous desired state, the new desired state, and the live state in order to merge them together in a way that preserved all the intents. That was tricky to implement. But Sam Goads from Box helped figure it out. What if you have arrays that are actually associative, and the key is one of the attributes and members of the array? Okay, yes, that was an unfortunate design decision. But so
strategic merge patch was one.
So server-side apply made that a lot easier, and made it easier for tools like Terraform and Spinnaker to do apply. And I think that got back my principle of, keep the client simpler and put the complexity on the server side. But you can see Terraform drew the line in a different place where it requires a lot heavier client-side orchestration, because a lot of these cloud APIs are designed not with the intent that you're going to apply and have the controllers just figured out, but you can create one thing as inputs, as outputs. You extract the outputs, you plumb them to the inputs of your next call, you make the next call, and then the next call, and then the next call. So those kinds of APIs are designed with the intent that you're going to be writing a program that is calling a sequence of APIs, which is not how people use the cloud, right? Like most people do resource management through tools, through command line tools, config tools, UIs, automation tools, right? Like the number of people who are writing programs that do some hard-coded thing is relatively small from what I've seen. There are some, more sophisticated people who build their own autoscalers for some system that doesn't have autoscaling, or, to build some higher level system on top in some way, or to orchestrate, multiple different workloads or jobs or things like that. But really a lot of those things become systems in their own right, and not just a single workload, right? Yep. And then we get back to the point of now you're using tools again. So with, I think a big thing that I noticed is that there wasn't a lot of awareness of the difference between control or management plane and data plane. So, like the data plane, yes, everybody will be calling the data plane from their applications. They'll be modifying, writing data in, databases and storage systems and messaging systems and AI, now products and whatever now, right? So those things, usually someone is writing code and they're writing it to do a very specific thing with a very specific service. So there, the RPC model is a good way to think about it. I think is a reason. And, calling A, then B, then C is a reasonable way to think about how the code will be written. But for resource management, it's just not. Right? Like, if you can think of what Terraform does, it does a get diff, and then based on the diff with the live state, it figures out what kind of updates you need to do. Do you need to create the resource, delete the resource, patch the resource, call some special method to update the resource, right? And I think that sort of mode of operation, whether it's done automatically or semi-automatically or by a human, is much more how we use cloud or Kubernetes. So, the more you can facilitate those kinds of management interfaces, the bigger your ecosystem and and community of users will be.
So sorry if I may, you mentioned that you're like a bottom-up thinker, and it's like super impressive. Like you're able to keep all these like different constructs, right? Like how they kind of interact with each other, and all these things like in your head. Like how do you?
I'm good at that.
How does someone go about like that's got to be like a skill though, right? Like, I mean, obviously, like.
I don't know. I don't have a problem with it.
Fair.
I have a problem explaining it, but I don't have a problem doing it.
Interesting. Like, did you always find that to be very easy, or like over time, like through different projects? Damn. Okay, just naturally talented. All right, that's a bit harder to replicate. Okay.
Sorry, Guang, you had a follow-up. Go ahead.
No. I'm just gonna sob in the corner at how little things I can keep in my own head. It's okay. Continue on, please.
So this is pretty cool, like in terms of how you came to many of the core design decisions for Kubernetes. And this is looking at the models you'd seen with Borg, with Omega. And you're not just thinking about how the architecture works, meaning how all these systems talk to each other. Instead of layers, you have peers. But you're also thinking about the UX piece, which is like kubectl apply -f, you pass a directory, just should work.
I'm happy that I think I designed the output for kube control git pods. I think it's still the same.
Oh, it's still the same. It's still the same.
So I said, I want to know, like if the pods are running or not. So that has to be in the output.
Yes. Now, one thing that I've been using Kubernetes over the last few years, been working with it. And one thing that you actually wrote in one of your blogs, by the way, you mentioned your blogs a couple of times. I highly encourage folks to check it out. You have a series of posts on Medium. We'll link to all of them in our show notes. There's a lot to learn from in just how you describe like the technical history of Kubernetes, the road to 1.0, and a series of posts on just, I would say, what people typically refer to as infrastructure as code. There is a lot of good learnings and a lot of context to learn from.
We can do another podcast on that.
Oh, for sure. So having said that, if you think about Kubernetes, it's similar to what you describe cloud as, which is it's more like Home Depot than IKEA, which is it's more DIY.
It's deliberately cloud in a box.
Exactly. But it brings the usability versus flexibility trade-off as well. Like, it's very easy to do kubectl delete -f. At the same time, if you're running something in production, you don't want that to be very easy. Like there have been, I forget which company it was maybe Shopify who described that they did something like kubectl delete -f and wiped out the infrastructure.
Spotify.
Spotify
accidentally deleted their clusters with Terraform.
Yeah. So when you make things very easy, some of these destructive actions also happen. So I wanted to get your perspective on this. Like, I've come to this opinion over time, not where I started with, whereas like every developer using Kubernetes should be exposed to Kubernetes, should just have access to kubectl and the manifest. Over time, I've come to believe that, well, Kubernetes is the right platform for platform engineering teams to build platforms on top of, make life easy for rest of the engineers. But you see many companies go through this phase where they start with Kubernetes being the interface and then slowly start abstracting it away.
I've seen the opposite many times as well.
Yes. Is this how you anticipated Kubernetes to be used in the first place?
Well, one thing I did is I looked a lot at platform as a service offerings and the degree to which they were successful or not successful, as the case may be. So I actually wrote one of my blog posts, Kubernetes and application platforms, kind of links to a bunch of things that I had looked at a couple years into the project. But, because we wanted to be flexible enough to run pretty much arbitrary types of workloads, like any kind of workload that we could imagine that Google would want to run, whether it's continuously running services or batch jobs or CI jobs or, machine learning workloads. I mean, that was really a thing back then, but MapReduce, we wanted it to be modeled after infrastructure as a service, which was clearly like, the standard flexible compute layer that everybody used. And all the platform as a service offerings back pre-container were just built on infrastructure as a service, right? So we knew that if we built an infrastructure as a service like layer, that we wouldn't build something that we'd have workloads that couldn't run on it. We also knew that, not only could we capture a lot of workloads, but we could capture these layers built on top. So we actually went through a period in the project where we deliberately chased other frameworks to get them to run on Kubernetes, like Cloud Foundry. It took them a while to switch from Diego to Kubernetes, but we did talk to them. We talked to the Slurm folks a long time ago because I had interned at Lawrence Livermore National Lab, so I reached out to someone at Lawrence Livermore, and it's taken them a while as well. But other things, we implemented ourselves, or we worked with the community, like Spark. We got Spark running on Kubernetes. We put a lot of effort into getting stateful workloads to run on Kubernetes, not just with stateful set, but also, other things that would be needed around that, like backups and persistent volume management and et cetera, et cetera. That was a fairly deliberate effort to say, look, we don't have to be platform as a service. We can, and I wrote this in the scope document and in the what is Kubernetes document. Also, like, Kubernetes is deliberately not platform as a service. Yeah. It is designed to run platform as a service on top. Because my experience looking at these systems is that as the platform becomes, you want to make it more ergonomic and reduce the number of steps people have to take. Yeah. When it's very generic, you have to configure more things, do more steps. There's more of an impedance mismatch. It's very free form. Yeah. On the other hand, making it very specific makes certain things not supported. Right. So there's this weird spectrum trade-off space, or, 2D plot, where you kind of want to find the sweet spot between saves a lot of time, reduces complexity, and also has a big enough set of workloads that it's worth doing. And that's really hard. Like, you can look out in the industry, and there are some folks who have found some good areas like that, like Vercel and Netlify, right? Static web apps. Yeah. Is it big enough because there's so many web apps, so many web developers. But if you go to a smaller niche, is there a big enough total addressable market in some sense to actually produce a platform product for that space? It's really hard because if you look at the combinatorial number of requirements, it's like, well, you may need to be internationalized and be able to represent everything in German, or you may need to have GDPR in Europe or some other compliance regime in Japan, or you may need to support streaming workloads. Like, if you're all these HTTP request driven workloads and you don't support streaming workloads, how do you build a chat app or something like that, right? Or if you don't support GPUs, how do you do inference, right? So there's all these choices you make that make it both easier to use and easier to build, but it cuts off most of the workloads that exist. So I think another factor in a lot of organizations is they don't want to have too many platforms. They always have multiple platforms due to acquisitions and organic evolution and what the history of whatever changes they have made. But I see a lot of platform consolidation efforts, and there seems to be like inherent resistance to having multiple platforms. So, but I think if you want to streamline the user experience, you have to have multiple platforms. If you have multiple categories of workloads, otherwise you end up with a one size fits nobody kind of platform. And you can build, some common underpinnings, and we did that with Kubernetes. There's probably more common underpinnings you can build, like cloud native build packs or whatever. But so I think for a specific organization, if you say, well, we have like a 10-year contract with Splunk, and we already chose Akamai for CDN, and they have some combination of technology choices they made, and that always ends up being a factor of how do you glue all those things together. It's like, we're using gRPC and GraphQL and Cloudflare or whatever. It's like, okay, why? But they are. So it's really, really hard to build a product that accommodates that kind of combinatorial complexity, but integrates it at the same time, I guess.
So one thing that you mentioned in the blog post, and this is something you see on the Kubernetes website too, where, like you said, Kubernetes doesn't say it's a platform as a service.
Yeah, I'm pretty sure the text I wrote is still on the site.
Yeah, I think it's a portable, extensible, open source platform for managing containerized workloads and services.
That sounds like me. Yeah.
Yes, I'm reading off of your post. So one thing which one of my colleagues recently said was, Kubernetes is like, see, it needs a style guide, which I completely agree with. And I think there are certain style guides if one squints a little harder, and they are in the form of in the design proposals you see this. In the community repo you see API conventions, spec and status, working with objects, declarative management of applications, how to use conditions, for example. But these style guides exist for platform teams who are building platforms on top of Kubernetes. Do you think there is a need for a style guide for PaaS itself, like platforms built on top of Kubernetes? Would community benefit from if Kubernetes took a stance on, like, here's what a PaaS on top of Kubernetes would look like?
Well, I am kind of surprised that surprised and not surprised, but kind of surprised that nobody's built a distro. So I was actually interested in the GlassCube announcement, in terms of like a package manager that would help you manage the components that are installed on Kubernetes. I pitched the idea of an add-on manager for many times, but it never really got traction to actually go build it. But much like a virtual machine, there's, common things that people need to install in their cluster, whether it's monitoring agents, logging agents, operators of various kinds, admission controllers, other CRDs, etc. So creating a way to manage those things and an opinionated set to start from. If you don't have your own opinions, like start with this set. And the monetization model I think is challenging, but enough users of Kubernetes have this challenge that I'm kind of surprised that they didn't band together in the community and come up with something like this. So I think that would be one starting point. Is just like, forget the paths, like just what is sort of a semi-standard way of running a cluster. What do you need in it? What should you install in it? Then if you wanted assistance with certain workload patterns, that's where I think it gets into things like, what CI/CD system are you using? Right. So that's where I think you could come up with, I think there are projects that are trying to put some high level guidelines. They're not very opinionated, but more of just explaining what is the shape of things that you need in your platform. I think that could go a little bit farther in that you could have a reference implementation maybe. Certainly, I would cover more of the gotchas that I've seen over the years, like what things to abstract and what things to not abstract, because everybody won't end up asking for those things, or how to do abstraction is another thing that I have a lot of opinions about, which maybe we can talk about when we talk about infrastructure as code. But because I think almost everybody thinks about them in the wrong way, or at least, in a way that's going to lead to predictable problems.
So talking about some of the gotchas, can you share a few that you've seen people run into more often than others?
Well, I think one is trying to hide some of the options in Kubernetes workload APIs, like the pod spec. So in Kubernetes, in deployment, stateful set, daemon set, jobs, etc., we deliberately decided to expose the full pod spec and not hide anything, because that would cut off some use cases, right? And I've seen this from the very beginning. Like I mentioned, Sam at Box, very early, they tried to abstract replication controller at that time with JSON, and it didn't work. Like, those fields of the API are there for reasons. So it all depends on how similar your workloads are. If you build everything with the same application framework and it runs the same way in the same footprint with the same kinds of integrations to application config and monitoring and logging, and it's very cookie cutter, then you can build a really narrow abstraction that just spits out everything for that cookie cutter scenario, right? On the other hand, if you are bringing in off the shelf components with Helm charts, those are going to be totally different. Kafka is a different beast than a Spring Boot app.
Yep.
That's a thing where my bottom-up thinking comes in, where I look like, well, what are the clusters of workloads that you need to run, and build abstractions around those. If there's just a singleton, then fine, that's Kafka. Just run Kafka, do whatever. On the other hand, if you have significant enough clusters of things, then you might build an abstraction. But if it's just one or a handful, it's probably not worth it. The ROI is just not there. The abstraction will get in your way. Like maintaining and extending the abstraction will be more work than just doing it manually on each individual thing.
One thing you often see is sometimes there is this tendency to consolidate platforms as well based on workloads, and like you said earlier, you end up with the least common denominator experience for every single workload owner, where none of them is happy instead of all of them being happy.
Right.
So Kubernetes is pervasive. Like, it's run on public-private clouds, on-prem, on the edge. You have this the Chick-fil-A example where they have been running it on the edge. I don't know how many thousands of clusters.
That's so awesome. It's in every Target store.
Exactly.
Yeah.
So that must be very satisfying to see. Obviously, something that you built, getting this sort of adoption.
It is. Yeah, I love all of the use cases that I never thought about, like retail edge and being in spaceships and oil rigs and whatever and wherever. We did design it deliberately to scale small. Like, one reason why there's just the API server, the controllers, and etcd, and not several stateful components like a database, a message broker, etc., is because we wanted to scale down and people talk about Kubernetes the hard way, but I think Cloud Foundry is a lot harder to actually run. We intended it for like at least local development or smaller footprint locations, but all the things people have done with it at the edge on Raspberry Pis, things like that, has been super exciting and interesting to me.
If I can, so I think the last time I used Kubernetes was like four years ago. So being a Kubernetes noob, I'm trying to fill my questions quota for this podcast. So taking kind of a slight tangent, but something you kind of coming back to is you mentioned like you're a bottom-up thinker, and you also mentioned that like you've only discovered this like in recent years as well, right? I was curious, like this is something that I think I talked to like our product leader at like one of my first companies. He's like top down versus bottom up, like especially for engineers, like in terms of, I think it affects a lot of things, right? Like how you communicate, how to be more effective, and all these things. I guess like, did you notice a big change when you discovered that you are like, or you confirmed that you're like a bottom up thinker? And then also it's like, should all engineers actually go and figure out like whether they're top down or bottom up?
I think it is worth figuring out. I think it would have been useful for me to have figured it out a long time ago. I'm sure people I interacted with and I generated like lists, 25 pages of bullets or whatever, they could probably have told me a long time ago that I was a bottom up thinker. My reading list or my list of platforms and things look like that. Like, I think my list of platforms was like 16 pages of bullets. But I do think it was valuable to understand, because then I just embraced it. But also I have to kind of fight it when I communicate to sort of distill down, realizing that not everybody is bottoms up and they're not going to get the message if I say, here's a slide that has 50 things on it. What's in common in those 50 things? It's like, no, it shouldn't be a guessing game. If you're interested, I can have a backup slide or put it in the speaker notes. But whether it's been useful or not, it's not been long enough for me to be able to say. But I feel already that I'm more effective. Whether I actually am, I don't know. But yeah, I do think it's valuable to understand that.
Nice.
Because then you can catch yourself in the sort of anti-patterns or figure out when you're talking to someone with a different modality and you need to kind of translate.
I see. And you said there's many signs in the past, but like, how did you go and confirm that like I'm bottoms up?
I started writing out, projects that I really enjoyed working on and what I did and what was in common about those projects. And, one of the things that was in common was areas where I could pretty much have free reign to figure out, what is the problem to solve, what is the solution. I could study the problem space and the solution space and kind of have control over the direction. So sort of a blend of product engineering and UX, I guess.
Cool. Sweet. Thanks. I got my quota. Please continue.
I don't know if that counts as a newbie question. It's a good question.
So couple of questions I have on the side of Kubernetes. Again, trying to capture some of your reflections on where it is today. Now, Kubernetes is used in all sorts of places, but it isn't perfect, as no system is. I'm curious to know, what are some of the things that, reflecting back on when you look at the system today, you wished were different about it?
So I thought about this question, and it's hard. I mean, there are things I know that, wow, I would, totally do that differently. But it's a tricky balance. So when we were building Kubernetes, it was not the first rodeo. It was like depending on how you count, I'd done supercomputing before. There's Borg, there's Omega. So we were able to get a lot of things right out of the gate without thinking too hard about it. But we also had to build it really fast. And our main goal was a container orchestrator, which is a term I resisted for a long time. But, we weren't building a control plane system that happened to do container orchestration. We were building a container orchestration system that happened to have a control plane, right? And we knew we wanted it to have a control plane and what shape that would look like and things like that. But it was not the main goal. It was kind of a necessary evil in some sense. And also, if you've read the System Bible by John Gall, complex systems have to start from simple systems, right? Like every successful project that I've worked on started with a simple skeleton and that had the basic shape of what you wanted to build and then grew from there. And now people complain about Kubernetes being complicated, and I understand where they're coming from. There's lots of resources. There are lots of attributes per resource. Cloud is no different. Like, is it harder to learn Kubernetes than to learn AWS, Azure, Google Cloud, and DigitalOcean and Oracle? I don't think so. I think it's actually easier to learn one thing than, several other things that are equally complicated or even more complicated. Like, what is the difference between IAM and AWS, Azure, and GCP? Like, I don't even know the answer to that yet. I'm just learning. But it started simpler, and the early adopters really loved it. And that was also super gratifying. Like, they immediately said, wow, this is awesome. It makes my life better in all these ways. I get it. It's cool. So having that core set of advocates who are kind of invested in the project. I mean, this is why we actually deliberately sought contributors to the project as well, is the IKEA effect of, it's more like Home Depot than IKEA, but the IKEA effect is when you feel more attached to something because you put effort into building it. And that really worked. I mean, it was insane and almost unmanageable to have 80,000 all-time contributors. But at a couple of years into the project, something like 12% of users had contributed. Right? Like, it actually it's super worked as a way to make people feel engaged with the project and with the community. And, we also learned lessons from like the Mesos community, where the big users didn't open source their frameworks. And there's a lot of fragmentation in that community. So, we were deliberately trying to build something different there, not just technically, but community-wise. So if we had started way more complicated, like if we had launched Kubernetes with the complexity it has now, could anybody have used it? I don't think so. Like, I actually doubt it. It would be way too much to absorb all at once. But we had this body of users and contributors that built up over time. And they only, had to learn new things as we added new features, and they could explain it to other people, and people could build on top of it and then extend those things. So we had like a smaller kernel to grow from. So it's hard to know, like, what decision, if we had done differently, sort of like the butterfly effect, like what would have changed in that process of growth. So that's a really hard thing to try to guess. But, in terms of things that, there are inconsistencies, like the associative list strategic merge patch stuff. I totally would have optimized for machine editability from the beginning, because if you look at Helm values files, I have a lot of complaints about Helm and the templating syntax and whatever, but I understand why it is the way it is, so that's a whole different tangent. But the values files are just nested maps.
Yep.
And because they're just nested maps, they're super easy to merge. So you can have a base values map and you can just overlay a environment specific value map on top of it and override values with no fancy schema information. Right? So having something like that that's structurally simple, that you don't need to figure out, like, is this a discriminated union or an associative list, or is it a set expressed as a list, or, like without, and those are just different forms of the problem I mentioned in Borg, where you had to like diff one field with some other field and things like that. So, it is systematizable. Like we did figure out how to go annotate the schemas with the information about what are the merge keys and things like that. But then because of the number of different clients in the ecosystem, it would have been better to optimize for machine editability and mergeability, I think, as opposed to human, thinking about in terms of human authoring. I think there would have been other ways to address the concerns we had about human authoring, like understanding is that map key a value or a key in the structure. Like that was the big concern about why we chose lists over maps. But whatever, I think that could have simplified a lot. Is it worth doing a V2 though? No. Like one thing that happens is you have to get stuff right to the beginning, or you can't change it because it's too expensive. It's not worth it. Yeah. So, there's a bunch of stuff. Like I wrote a V2 API issue. I think it's like 8210 or 8120 or something like that. But let me just check to see if I'm starting to forget the numbers after 11 years.
It's it's still pretty impressive that you remember some of these numbers. And I see this show up in your blog posts as well, where you have links to a lot of the issues on GitHub, which is quite cool. And I think that is one specific thing I would encourage folks to check out. Like, go on those tangents, read through the issues, because all of that history adds to one's understanding of why the system was built a certain way. At least it has contributed to me knowing more about the system and using it more effectively.
Yeah, so I did not remember that issue number. Oh, here it is, 8190. All right, 8190. But yeah, so we never implemented any of those things because it just doesn't worth it. It's kind of sad because it's like a wart in the side for all history, but the ecosystem of stuff that's been built in everybody's configurations that are using the current API is just too large for it to be worth changing. I do think there's some smaller things that could totally be implemented, like garbage collection of config maps. I totally think we should.
Oh, yes.
Garbage collection config maps. I'm so sad that the two proposals that we had to do that just did not go forward. But what else? I mean, we could have made, if we were doing a control plane, thought of it as a control plane project from the beginning, as we could have made everything a CRD from the beginning. But that was so much harder to build. Like the initial third-party resource thing had to be totally scrapped and redesigned. We had to build aggregated APIs first as a way to decouple that API server, and then it took years before it was GA. And even now, do we have binary encoding yet? Like, I don't even know if we have binary encoding yet, right? So it was much harder to build in a very generic way. So it was totally the right call to not require that from before we even knew if it would survive, right? Like, we didn't know if the project would be successful. There was tons of competition. There were dozens of other projects out there. I kind of figured that libswarm wouldn't be the winner, but other than that, we really didn't know.
I'm reflecting on like what you were saying with the just like you have to get it right in the beginning, or otherwise like there's right, like in so much of software engineering, I feel like there's the whole like iterative sort of agile aspect to it. But then when it comes to this, it's like, to your point, like
APIs are forever.
You only got one shot. Yeah. That's,
yeah, you really only have one shot. I mean, API versioning conceptually exists, but in practice, probably we could have done without it.
I like that line. Ooh, that's damn, that's good.
So, one thing you mentioned earlier around keeping the surface area of Kubernetes small in a way, and I think that attracted a lot of users, or made it easier for a lot of users to deploy it in many different places, where you have a few core components, you get them running, and you have a functioning cluster. On the other hand, for some of the bigger users or so-called hyperscalers, it doesn't quite just work out of the box because the surface area is much larger than the boundary of a cluster. And this is true for like places like Google, for example, where the number of Borg clusters you have is it's not just one, for example. Similarly, any company at a decent scale would not have just one Kubernetes clusters. So do you think there is room for something like Kubernetes or Kubernetes in a different form that could work for some of these hyperscalers too? Or like there have been projects around multi-cluster Kubernetes, for instance, but that area is still very abstract and undefined, and everyone is kind of just figuring it out themselves.
Yeah, I think there are a couple of ways to look at it. One is managing multiple fleets of clusters. I do think that's the original Federation work did not go the direction I was hoping. So what Borg does is every cell is independent. So the compute clusters are independent, but there's a mesh for service discovery and authentication that spans clusters, right? So I had suggested, I think that, Federation should kind of focus on the networking, naming, and auth areas to try to just start there. And it kind of grew to the entire API surface. Borg did have another kind of proxy for launching workloads on arbitrary Borg clusters, but those were batch jobs. And it also just it didn't have the same problem as, like emulating all the dozens of built-in types plus all CRDs and all the behaviors across multiple clusters. So we did talk also another use case. So I guess the short answer is have in mind what your use case is. Like if your problem is retail edge, then the shape of your solution is probably different than if you are sharding a cluster for high availability within a huge data center. And if your workload is a continuously running service, it's probably different than a batch job. So if you build a more specific, I guess another thing, observation about higher level abstractions is they tend to be more valuable if they're not just kind of restricting you and generating a pattern of config or API calls, but they're actually actively managing the underlying systems for you. So one example I call out is Spot, right? So Spot lets you run a workload on at lower cost, and it manages the underlying VMs for you. If they vaporize or expire, it starts your workload on another one, right? So that is providing an active service that's kind of complicated for you to build. It restricts what you can do, but it's providing value for what it does, right? So I always look at that sort of ROI of the abstraction layer, like how much is it doing for me versus how much is it restricting me. So I always look for it to do something non-trivial. If it's something I could just write a config generator to do, then I probably don't need it. And it'd be better to not have it because it's operationally more complicated and will restrict what I can do. So yeah, with multi-cluster, it's definitely it's very dependent on the work case. One thing about the Kubernetes design is it was designed with specific technical and business goals in mind. It wasn't designed to scale to 100,000 nodes deliberately. In the beginning, it was just literally said, well, it will run on 100 nodes, right? And we grew that to 1,000, 100, I forget what the progression was, but 1,000, 5,000, 15,000. Because we assumed it could run on a single node, the whole system could run on a single node with the API server, the controllers, etcd, and the kubelets. And we weren't going to depend on infinite cloud storage or, having PubSub available or, some global control plane building blocks. That limited the design, but the design was really focused around flexibility and extensibility. And like I said, the ability to scale down more than the ability to scale up. So, if we were designing to run a global service, it would have been designed totally differently. Like Watch is super expensive. It was designed for the case where there is a relatively small number of rapidly changing entities that need to be continuously managed by controllers. So they always need to have the state in memory, right? If that's not the scenario, it doesn't make sense. to use that model, right? Like if you have a very large, like if you're a shopping catalog, if you have a very large inventory of stuff, most of which nobody looks at most of the time, or it doesn't change most of the time, then you wouldn't want to keep all that in memory and send constant updates for everything, right? So you wouldn't use that model, right? So it really depends on what you're designing for. So if you wanted to design a system to use GPUs all around the globe to do, batch inference or something like that, I would design it totally differently.
So there are a lot of things people agree on when it comes to Kubernetes. One thing which there's not quite a lot of consensus on is how to manage manifests and the infrastructure as code space. We're going to park this section based on what we talked about earlier. We can do a round two when it'll be more appropriate to talk a little more about that. So is it cool with you if we park this? I think it'll be more appropriate to talk later.
Yes, thank you.
Okay, cool.
Yeah.
So having said that, moving on to some other aspects of just how you operate as an engineer. So you were a distinguished engineer at Google. You've been an Uber tech lead on many projects. What are some of the practices that you found to be helpful when working as an Uber tech lead and you're collaborating with a bunch of other senior engineers too? And I should also maybe ask, for some folks who may not know what an Uber tech lead means, would you mind describing what that position is?
Sure. An Uber tech lead is... I actually found, the term is out there. I don't think it's just used at Google. I'm not even sure that it started at Google, but Uber is like over in German. And, it's basically a tech lead of tech leads. And, so you may not be doing the day-to-day, hands-on coding, issue management, things like that, but operating at a higher level. Like a standard progression that I see at Google, a staff engineer at Google could be a tech lead of a team of maybe 10 or 12 people. And, I think of them as kind of in partnership with the eng manager and a product manager if there is one, and maybe a project manager if there is one. Shouldn't really be one at that scale, but as running the whole software project. Like they know enough that they can decide, do you do Scrum or Agile, or, what are the practices that the team actually uses to stay on the same page? How do you do issue management? How do you do version control? How should you do CI? Now, like some of these come from the broader organization, or you just start using some tools, but they're capable of like making or at least evaluating or implementing all those kinds of decisions about how do you run a software project, right? And they will often be doing some amount of the coding, doing design work, overseeing design work, doing code reviews, making sure the project hits its milestones, like I said, in some cooperation with the eng manager and other folks. But if you just throw like a software project at them, they can figure it out. They can ask questions to the product manager if it's not clear. They can engage UX, things like that. A level above that, like senior staff level, could be someone doing that with a bigger project that's like 2, 3, 4, 5 times bigger. Or probably if the bigger the project is, we'll have more tech leads. They delegate different components of the effort to, right, who'll be doing those kind of day-to-day activities I mentioned, so they have the ability to up level what they actually do. Maybe make sure that your director knows that you need more product team coverage, or things that are kind of more meta level, more organizational level, as well as doing some of the critical design oversight or design work, thinking more about the strategy, working together with the product team in terms of the roadmap and how quickly things can get done, where the risks are, whether a change in direction is needed, figure out when to burn down technical debt. Because a lot of times people in the trenches have trouble popping their heads up to reflect. I have that problem even now. And it's helpful to have someone who's not swamped by the day-to-day. I mean, they can, if you have external customers, then you can also engage with customers and things like that. So I think the Uber tech lead role for a larger software effort can be pretty important to make sure all the pieces of the architecture fit together, that you have reasonable conventions across all the teams, and you're all hitting consistent expectations, right? Like you don't want to have one team thinking, oh, we only have to be 3 nines, and some other team saying, what? We're totally doing 5 nines. Like you need some sense, a decider and clear messaging about those things. And, if teams aren't communicating with each other or aren't sharing designs with each other, they may set practices for and expectations for how that stuff is done. Like I said, together, depending on what the eng manager and the Uber tech lead carve out as their responsibilities. But a lot of, especially in the kind of cloud space, I mean, these are products built by engineers for engineers. So a lot of decisions are super technical, even product decisions are UX decisions. And a lot of the customers are super technical. So it's useful to have senior technical people engaged with all those cross-functional roles. And Uber tech leads usually do a lot more of that, in my experience, because they are freed from some of the day-to-day responsibilities more. And, some of them really like coding, even up to the most senior levels. I find I've barely written any code at Google. Like, honestly, I did most of the coding in my career from in the previous couple of decades. And then as time went on, I did it more at the early stages of projects when we were figuring out what is the design, what's the architecture, what are the concepts involved, or for prototyping or certain squirrely pieces. Like, I'm really good at memory consistency model stuff. So I can explain the x86 consistency model to you, stuff like that. Like, why do you need a memory barrier after read? Like, I can explain that to you. But otherwise, I don't feel like I really enjoy it. Like, I spent almost all of yesterday doing coding. It was awesome. But I don't feel like I really need it because I have the bigger vision for kind of where I'm wanting to go, and I'm kind of comfortable. I read this article about giving up the Legos. I had to do that repeatedly on Kubernetes. Like build one part, hand it off, design one part, hand it off, get a SIG started, hand it off, create the doc site, hand it off, right? Like, I just had to do that over and over and over again, almost monthly, I think, for a few years. And I'm pretty comfortable with that. So I think an Uber TL has to be kind of, because there are more moving parts that they are responsible for and that they're exposed to, they also have to be more comfortable with that. It's like that somebody's going to take care of it, as long as it's clear who's doing it and what the expectations are.
So when working with other tech leads who you are giving away your Legos to, how do you set those clear expectations with them? And how do you effectively give away that Lego?
I think, it's really hard. I think there was a good blog post about that I didn't write about senior engineers going into a new organization. I can dig up the link later if you're interested for notes or something.
Oh, yes, please.
I found that to be true even within the same company, right? So if you have a small project and you pick the right people and they can grow into leads, and as the project grows, those people grow, that's like the best case scenario, because then you have a set of people who understand the project inside and out, who've worked together for a really long time. That's totally the best case scenario. So Kubernetes was like that for many years, and it was great. My previous startup was also like that. While the startup was around, we started with the right people, and as we grew the team and grew the software, they became the leads of their own areas, but were able to work really well together. If you go into a new organization, it's pretty hard because you have to get to know people. You have to get to know how the organization works. You have to be more explicit about things and kind of document, this is the procedure I expect, or you have to try to adapt what exists currently and then maybe pivot it a little bit if it's not meeting your requirements, and you have to explain why you're pivoting it. And you have to communicate things over and over because, people change all the time, people leave, people join. Also, it is, just hard to keep all these things in mind when you have all other kinds of time pressures and whatnot. So it does help to be organized, maybe more organized than I am. I think at some level, I try to write down my ideas and my thoughts, but it tends to be brain dumpy, and it takes me more effort to sort of turn it into something more structured. Like you've seen the Kubernetes API conventions, I think, it is kind of brain dumpy. I wrote that doc pre 1.0, and just sort of expanded it a little bit after that, but never turned it into something like AIP.dev that is a lot more structured, right? Because I gave up that Lego and went on to something else, right?
I would say there's still value in reading the entire context, by the way. Like when you read someone's brain dump, it gives you perspective into how they are arriving at the decision, and you don't just see that last decision itself. So many times I find that to be quite helpful.
Yeah, I mean, it does take deliberate effort. Like for Kubernetes leading up to 1.0 in July, just weeks before we announced 1.0, I read through the pile of markdown docs that we had and realized it wasn't clear how to use Kubernetes. So I started an effort to write a user guide. So I actually wrote the outline, broke down each section. I wrote most of the sections, handed off a couple of them, and that became the original like user guide for how to use Kubernetes on the Kubernetes.io. So I think something like that, but for how to organize your team, like what do you expect in terms of design docs, creating the design doc templates. At a larger company like Google, a lot of this already exists, and you more just have to kind of say we're going to use this template and that template, and we're going to do things this way, and we're going to use all the standard tools and whatever. And if there's multiple frameworks, you got to pick one, that kind of thing. So documenting. Maybe some of the decisions are arbitrary, so there's not necessarily a why. It's just like we have to do something. These are available. Let's pick one that's good enough and move on. That's totally fair. It's a little bit unsatisfactory to people later. But yeah, when I joined the Borg team, like there was tons of stuff not documented. Like I asked, what does Borg even do? And it's like, there's no documentation. So
It runs jobs.
yeah, there was not a satisfactory explanation of that. So yeah, I guess thinking about like what's going to happen when you leave or after you hand it off, like what do you want to not be dropped through the cracks? Think about that and prepare for it. Like when I was preparing to leave, I thought about this exact thing and thought about who's going to take over, what do they need to know, what artifacts do they need access to, is there stuff that's not written down that needs to be written down, things like that. So that took several months to do that.
And zooming in on like when you were handing off like say a project or like a Lego piece, as Ronnie was saying, say if you bring it up and then like 3-4 people both like all volunteers like, oh yeah, I would love to work on this on this project. How do you like pick in terms of like what attributes do you look for in engineers that would make them like a good person that will like take it forward?
I don't think I've ever had that problem. Like usually nobody wants to do it.
You just gotta throw.
I mean that is a scenario when companies are hiring, right? Like, so you have to choose someone. So I think I hate hiring. It's hard. If you've worked with someone before, it's easier because you can think about, well, much like I did with myself. What have they been good at? How have they responded to different situations? Were there any areas where they need to improve or things that did not go well? Why did that not go well? Some of the things are situational, so you can kind of think, is it a good match? Like definitely one thing I've learned is that early stage and late stage are totally different, right? Like if you want to start from a blank sheet of paper, you need a pretty different person than someone who is going to try to make sure everything is just right. Right, like that you just can't afford the time, and also you need that spark of creativity, that people who are comfortable with ambiguity, like I mentioned before. If there's multiple ways of doing something and you're not even sure if people are going to care about your software, pick one that's kind of good enough and move on. It takes not everybody's comfortable with doing that, and some people are very comfortable with making product decisions or UX decisions or something that they view as sort of not their expertise or not their job. They may be worried that doing something that they've never done before that's outside their area of expertise. Those kinds of things can slow down projects that are just getting started. Some people are it just doesn't bother them, but that's kind of good because at some point it becomes a pain point. Like once you have customers and they expect the product to be stable and you can't just break things all the time or do random stuff that you have to support forever. I think one thing is just being a good role model, right? Like everybody saw me writing all these sections of the user guide. I didn't get pushback from anybody asked to write a section. like not even a single person. So, if you show people that you think it's important enough that you're going to spend your time on it, that seems to work. I think something else that I did is look for examples in other products and other systems that people thought were good. Like, what do you think a good way of documenting help for doing certain tasks is? Like, can you think of a good example and where that was useful to you? It's like, oh yeah, GitHub has a really good page for like how to get help on doing any random thing. It's really easy to search in their help page for that. Or like Stripe has really good API example. Whenever I integrated with that, I could always find the answer to my question. Or, like Stack Overflow always has the answer for this system, right? So then you can say, okay, like that's going to be important to our users. Can you help make that happen for that area, right? So if they can realize like, oh, it's actually been useful to me, and there's an example, and you think that would apply in the situation, that gives them some agency over the solution.
I see.
Another thing that I think is good is sort of brainstorming mode, and I think AI will even make this easier, where it's like, so one thing I find about writing is it's important not to get too attached. Just like write a draft, whatever, just pound out, like do the brain dump, get the information out there. If it's worth polishing, go back and polish it after. You can like cut whole sections, redo parts of it, write it a totally different way. But once you've done it once, it's not so intimidating and easier to edit than to do it from scratch again. For me, at least, like, I don't know if everybody is like that, but for me, I find that super effective. It's just, just don't be attached. Like I learned that when doing my PhD thesis.
That's real. That's real.
That's like 250 pages, right? And to some degree, some of it is, multiple previous documents bolted together, but, some of it had to be written from scratch, right? And if you get writer's block, it's a pain. So if you always want to be making forward progress, just get into the mode where you can always feel like there's no reason why you shouldn't be able to make forward progress. Like, I'm going to write about this, and you just write stuff about that, and maybe it will be good enough that you can just keep it. Or maybe you can ask ChatGPT to fix it. I don't know. But getting the content out there, at least for me, being the bottoms up thinker, helps me think, oh, like, why am I saying this first? This other thing needs to come first. I'll just reorder them. And I'll just like reshuffle everything. And of course, none of the text will flow. But then I can just like go turn it into paragraphs.
Nice. And
I think this is
so it's just that iterative refinement process works for me.
Nice. Right?
I was just going to say that this has come up a couple times in some of our previous conversations with as well. Like recently we were talking with Kyle Kingsbury, and he mentioned a similar style too, where it's like just spew everything out, like just write it down without judging what that looks like, and then you can always go post edit, and that'll help you get to a final outcome instead of trying to make it perfect from the start.
Right, and for engineers, if you have the help with a tech writer who can do editing, or in the pre-ChatGPT era, the number one thing the engineer needs to spew out is what is the thing, what are the knobs, what are the features, what are the details. And once they do, then the tech writer can come in and say, yeah, but a user is probably going to want to do this, and you didn't explain that. How do you do that? And then they can fill that in. And you can say, yeah, but this thing doesn't make sense to me. It's like, oh, actually, that's a bug. I meant something else, right? So someone else can, like, once they have enough to even know what it is you're talking about, they can kind of extract the additional details, the structure, resolve the ambiguity. And that worked really well. So one thing I had to do with Kubernetes is campaign to get dedicated tech writers working on the Kubernetes open source project, and not just product documentation. Because a lot of Kubernetes vendors just wrote their own product documentation. Yeah. And I argued that, look, you can read what the engineers wrote, but it's not going to be good if nobody can use the open source project. And, I could spend all my time rewriting it, but I don't think you want me doing that. So we were able to get a good doc writing team, multiple people actually working on the Kubernetes open source, and I actually had to go to other vendors in the space like IBM and get them agree to put people on documentation. So that was a deliberate effort that I did through my, wearing my Kubernetes steering committee hat MIC and CFTOC hat saying like, look, you don't want to contribute, software engineers, how about documentation? That would be super useful.
Interesting.
So that actually worked.
Yep.
Nice.
Brian, this has been an amazing conversation. We'll definitely do a round 2 and chat a bunch more about UX, infrastructure as code, and a whole bunch of other topics. Before we close this, is there anything else you would like to add?
No, it's been a good long conversation already. I think it's a good stopping place. Yeah, you had a great selection of topics. It was a lot of fun.
Awesome. Thank you so much for joining, Brian, and thanks for taking the time. This was amazing.
Yeah, it's great talking to you.
Hey, thank you so much for listening to the show. You can subscribe wherever you get your podcasts and learn more about us at softwaremisadventures.com. You can also write to us at hello@softwaremisadventures.com. We would love to hear from you. Until next time, take care.